Welcome in this tutorial. I am going to explain how to perform a response spectrum analysis of a 3D being. So on a screen, you are seeing one 3D building. So this building I have taken from the literature. So what are the different loads acting on the building, that is usual type of the load. So this is already defined and assigned. So this is the building. So this is already modeled. In my previous video, I explained in step how the model, this particular model is created and how the different loads have been assigned. Now we'll move forward for the next analysis, that is response spectrum analysis. So the data required for the response spectrum analysis. So that is site is located in seismic zone number 4. Then building is resting on medium soil, the soil type number 2 as per IS 1893. Then important factor is equals to 1, and building type of the frame is a special moment resisting frame. So these are the data we required for the analysis using response spectrum. Then we'll go into the SAP window. Now before to move forward, so first of all, it is required to perform a modal analysis because this response spectrum analysis method or analysis, it is a modal combination based method. So therefore, it requires the data from the modal analysis. So first of all, we'll perform modal analysis. So already the modal analysis, modal load case have been defined. So therefore, we will run the analysis. So that is the first step. So perform the modal analysis. Okay, now the modal analysis has been completed. Now just we'll see the results in tabular form. So here it is structure output. Go to the structure output. Now there are two options: base reaction, modal information. So go for modal information. So in this, okay, select a load case. So it is a only modal load case we have run. So therefore it is say okay. So this is the table, different tables obtained from the modal analysis. So right now we require only one table, that is a modal mass, that is time period of each mode. So that is required. So just we'll export that particular table into the Excel format. Once again, we'll see the table. So it is a display show table, structure output, and say okay. So it is taking some time. Okay. So now the table is generated. Only second table we required. Now this data, this particular table will export into Excel. Yes, now this is the table. Okay. Okay, now we'll unlock the model. Unlock the model. Then we'll go for the second step of the response spectrum. So second step is define the response spectra. So we'll do the response spectra analysis by using IS 1893 response spectra. So first of all, define that particular the spectra or the spectral function. So how to define the spectral function? So go here, define, then it is function, define function response spectrum. These are the commands. Okay, then in this case, just click on the drop down list, and these are the different spectra from the various codes from different countries. So search for IS 1893 2016. So this is this particular IS 1893 2016. Add this function. So click on add new function. Add new function. Okay, then function name. So this response spectrum is IS 1893 2016 is the function name. Okay, now this information. So seismic zone. So this particular building is located in seismic zone 4. Okay, then important factor is given in the data as a 1. Soil type is a medium soil type. So type number 2, it is a special moment resting frame. So response reduction factor is 5. Okay, and by default, the damping, it is a 5%. 5%. Okay, so this much is the information required to fill. First is seismic zone, that is this value. Then seismic zone factor, automatically it takes. Then importance factor, soil type, and response reduction factor. 5% damping, okay, is the default value as per IS 1893. And whatever this table, these are the spectral acceleration value for different the periods. So this is the periods in second, natural periods in second, and this acceleration, that is spectral acceleration value in terms of G. Okay, so all these values are in terms of G. Then after filling this information, then click on OK. Click on OK. Okay. Now the function have been defined. Okay, now we will create the load case. We have defined the response spectra function, then we'll create the load case. So go for define load case. Okay, to define any new load case, this is the command. Okay, so in this, we'll define the load case. Now we'll perform this response spectrum analysis in global X direction as well as global Y direction. So separately, it is required to define these two the cases in X direction and in Y direction. So first, add new load case. Add new load case. Okay, then here load case name, it is response spectrum RSP in X direction. Okay, then it is a load case type. It is a response spectrum. It is a response spectrum. Okay, now here, now interestingly, this is the important thing. So this is the combination, modal combination rule. Okay, now as I said that response spectrum is a modal combination based method. Modal combination based method in the sense it estimates the lateral forces in each mode and afterwards it combines. Now for the combination of the result from different modes, it uses the methods. So for the combination of the results from the modes, the methods given in IS 1893 are the three methods given. First is SRSS method, then CQC method, and absolute method, summation method. SRSS in the sense square root sum of square, then complete cubic quadratic is the second method, and absolute method is the third. Okay, and same for the modal combination. Now, which is the appropriate choice for the analysis here, for example? Now, this depends on the results from modal analysis. So therefore, we have performed modal analysis first. So result in the sense, just we required the time period of each mode. Time period of each mode. Okay, so therefore, you just see this is the modal analysis table. Modal analysis table on this. So all the values are not required. Only just refer this and this. These two tables. Okay, so these are what sorry, so this we required the value from this column and this column, right? So these are the mode numbers 1, 2, 3 and so on. Okay, and these are the periods of each mode. Okay, first mode, this is the first mode. What is time period? 0.53. Second mode, what is the time period? 0.49. What is the variation between the time period time periods of mode 1, mode 2, is this variation is within 10% or more than 10%? So I think it is more than 10%. So we say that mode 1 and mode 2 are well separated. Similarly, mode 2 and mode 3, again time period, again variation is more than 10%. Again, mode 2 and mode 3 are well separated. Similarly, 3 and 4, 5, 6, if we compare, modes are well separated in this case. And if the modes are well separated, variation is more than 10%, then for the modal combination, use SRSS method. And if the this variation in time period is less than 10%, what is called as a closely spaced mode, then in that case, use CQC method. Some structures, some models are such that few modes are closely spaced and few modes are widely spread. So in that case, go for the third option, absolute sum. Absolute sum. So in this case, go for the option first, and here also go for SRSS method. Next. So this is a response spectrum analysis. Okay, so this requires the results from the modal analysis. So by default, SAP 2000, the option is a modal. Then next, here now in this particular table, this table is important one here. So this now we are defining the response spectrum in X direction, right? So therefore here must be U1. This is the function already defined. Here. And now the scale factor. Now, while defining the function, we have seen that spectral acceleration value, all the values are given in terms of G. So therefore it is required to convert into accelerations. So therefore multiply each this thing by 9.81. The scale factor will be equal to 9.81. Then add this. Okay, add this. So this is the only thing we have to define. We have to fill the information to define the load case in response spectrum X direction. Okay, say okay. Then in the similar way, define in the Y direction. So therefore, response spectrum X direction load case, you just copy here. So go for second option, add copy of the load case, and then make necessary changes in Y direction. So therefore, RSP Y direction. So this is SRSS, this is modal. Here only in this table, instead of U1, it is said to be U2. Okay, and then modify this. Okay, here only it must be U2. And then say okay. Now both load cases have been defined. Now we can start the analysis. So for the analysis, these many number of cases are there. So all the cases are not necessary to run. Okay, so only the modal load case. Okay, modal load case it is required. And next is lastly it is a response spectrum X direction and response spectrum Y direction. Okay, only these cases we will run. Okay, now the analysis has been completed. Okay, so now we will see the displacements. Okay, we'll see the displacements. So this is also a okay. Now to see the displacement at every node, so go for display, then deform shape, display, deform shape. Okay, then select here, say response spectrum in X direction, apply and okay. Apply. So here, this is the response spectrum in X direction. So that means the force is applied in X direction. So obviously there will be displacement at every node in X direction, not in the Y direction. So Y direction coordinate, displacement coordinator must be 0. So anywhere just keep the cursor on the point. So we'll see U1 is how much? It is 5.4 millimeter. U2 and U3, these are 0. U2 in the Y direction, U3 in the vertical, these are 0. Okay, now here in this window, we'll see deformation in say y direction. So deformed shape in say y direction, apply OK. Okay, so this is deformed shape in the y direction. So in the y direction, in this sense, force has been applied in y direction. So therefore, only y coordinate will be there. X and Z coordinate will be 0. So keep the cursor here. Okay, so we are saying U1 is 0, U2 is how much? 4.6 millimeter, and U3 Z direction is almost 0. And R1, R2, R3, these are the rotations. Okay, rotations are also 0. So only translational displacements are there. It means, so this is in this way displacements are to be shown. Then we'll see the base reactions, what is called as a base force, base shear in X and Y direction. So go for display, show table, display, show table. Then base reaction in the sense total structure base reaction. So go for structure output, and here choose a base reaction. Here option should be a base reaction, and then select the load case, and then say OK. These are the steps to see the results. Okay, so base reaction, select load case. Okay, so we'll see the load results are RSPX, RSPY. Okay, and then say click on OK. Okay, now these are the base reactions. So what is the base shear in X direction? So this is RSPX. That means base reaction, base shear in X direction. This is X direction is equals to how much? 198 kilonewton. Okay, then RSPY, base reaction in Y direction. This is FY. How much it is? 197. That is in X direction, Y direction, almost the same base reaction is there with negligible changes. Okay, while as know this thing in the Z direction, base reaction in the Z directions. Then this is the moments. Okay, so this is the moments. So this is global MY. So the moment when the response spectrum is performed in X direction. So the moment with respect to global Y direction, how much it is? It is 1967 kilonewton meter. Okay, and when we perform RSP Y direction, then the moment with respect to global X direction is equals to 1483 kilonewton meter. These are the movement with respect to global X and global Y direction. So these are the base reactions and base movements. Okay, then we'll see also the internal forces, that is member forces. Okay, so therefore go for display. Okay, this is the command to see the internal forces. Show forces, stresses, and say frames. So first of all, we'll see the result from RSPX. Okay, then we'll see first of all bending moments. Okay, so bending moment M33. Show values also. So at the bottom there are two options. Only the bending diagram with some colors is your requirement, or you required some values also. So yes, we'll require the values. What is use up to see the only colors? Okay. So go for second option. It is show values, apply, and OK. Okay, so these are the bending moment diagram. So 3. So this is a frame XZ. We'll see YZ also. So there will be only bending moment bending in XZ plane. Okay, so then next is, if we see so see, we can see the values also. So at the center it will be 0 in the column. At the center, these are the point of counterculture. So at the top it is 10.62. So the moments are greater magnitude at the bottom, and the moments in the beams are also there. If we see the 3D diagrams, Okay, so these are the bending moment values. So when we click on any member, okay, right click, okay, so the detail of internal forces, so it is displayed, right? Okay, so this is the resultant shear value. So resultant shear value, so how much it is? V2, it is 1.48. It is negligible shear force. Resultant movements are, okay, so resultant movements are, so this is the reference value. When this is, it is at the center, moment is equal to 0. Okay, so it is maximum at the end. How much value? It is 3.64 C. Okay, so these are the moment value in this particular the beam. For this is for RSP X case. Then again, to see the results on the column, just right click on this. Yes, the maximum moment in the column is 10.61 here. That is at this point. Here, the stick is here, so it is a 10.62. And what is the shear force? It is 5.84. So these are the results at the top. So generally, the column which are at column and beam which are at the base level, so it has a more values. So we can see also here. So intermediate column, click on this. Height is 27. Moment is 27. Shear is also 16.88. So in this way, we can see the results for the RSP Y case. So this is a response spectrum analysis. So then after performing response spectrum analysis, then the building is designed as per IS 456. So the design of this article